Evaluate variable expressions for number sequences. So evaluating means we're going to plug a number in, we're going to solve it, we're going to simplify everything until we get down to one thing. And then that'll give us the answer. So whenever we're evaluating, we're going through and we're solving. The thing to remember with sequences is that anytime that you have a sequence, the x values or your domain is going to be all of the positions of the numbers. So for example, the first number in the list would be 1. And then if we're looking at this sequence, you can see here that at the bottom, it's going to be 8 as your range value. So whenever you have sequences being given to you, you're going to wonder, where are all the x values? Where are my inputs to be able to evaluate this? Well, your inputs are going to be the position of the number in the list of numbers. So the fourth number would be 4 for your x value. The 52nd number would be 52 for your x value. You'd plug that in, evaluate, and then it would generate that number of the sequence, the 52nd number in the list. So n is also a thing you should look out for whenever you're seeing something that looks like a function, but it's got the variable n in it. And then you're sitting there going like, I can't find my x values. That's because you're talking about a sequence. Anytime a sequence is coming up, again, your x values are going to be the position in the list. So let's go ahead and just take a look at some examples. So find the first 3 terms. So it's going to say a subtext n, and that's going to be the term and then the number that it's in the list. So the way that this is going to look is whenever we want to find the first number in the list, we're going to say the first term. Then we're going to use n as 1 because I want to know the first number minus 10. So whenever we solve for this, we're going to know that the first number in the sequence, a subtext 1, is going to be 9 times 1 minus 10. Now we evaluate, which is 9 minus 10. And then we know that a1 is equal to negative 1. So I'm going to go down here and I'm going to put the first number in the list is 1. Let's try to find the second one. A2 equals 9. And instead of n is the position. We're looking for the second number in the list. So we're going to do 2 minus 10. Evaluate. 18 minus 10. A subtext 2, or the second term in the sequence, is going to be 8. Then let's go ahead and do the third one. The third term is going to be 9 times the third term in the sequence, minus 10. Evaluate. 27 minus 10. The third term is going to be 17. So again, just to work backwards, to say, okay, I got 1, 18, and 17. What does that mean? Well, that means the first term was 1, and it's the first number in the list. The second term was 8. That's the second number in the list. And the third term was 17, which is the third number in the list. This is going to replicate your X and Y table. Something just to keep in mind in case you wanted to plot these. So the first 5 terms. I'm not going to do the first 5 terms. What the difference is between evaluating expressions for number sequences versus recursive sequences is we can go through and we can put in any number for n, and that will be that number in the list. So for example, if I want to know the 5th term, I could simply say, all right, well, I want to know the 5th term. So the 5th term, a subtext 5, would be 4 times to the 5th. 4 times n raised to the n, which is 5 in this case. So all we're doing is taking that n and putting it in for n, just like we would a function. So a to the 5th equals 4 times 4 times 4 times 4 times 4. So 4 times 4 times 4 times 4 times 4, which is 1024. Okay, so we know that the 5th term is 1024. And we can substitute 4 in, and that would give us the 4th term, and 3 in, that would give us the 3rd term. So what's cool about sequences is you can substitute any number you want in for n, and it'll tell you what that number is in that place of a list of numbers. Cool. With recursive sequences in the next section, not not so simple. So find the first 5 terms. I'm going to go ahead and find the 5th term again. You can see that n is going to be moving around. It could be an exponent. It could be something you're multiplying by. It could be something you're dividing by. So a subtext 5, and we're going to 5 times the 5th place, which we're going to evaluate and get 25. So the 5th term in the list is going to be 25. So if we did this, I know that the 5th term is 25.